up or not, or what's the bandwidth of the link?
What is the
Actually, sir,
yes?
what will happen? Say, for example, if the two routers are connected with each other,
Okay,
and if we are running OSPF on it, so basically they will have a database that is
okay,
a link state database, and any change in the topology, for example, in router one or router two, it
mm-hmm.
will send that particular thing as a link state advertisement to the other router. So
Okay,
that basically means link state.
okay. If you will remember the properties of link state, so link state routing protocol maintain three types of table:
Yes, sir.
neighbor table,
Route
database, and routing table.
Database.
It send periodic as well as trigger update. It
Yes,
send partial as well as full update.
yes.
So these are properties of link state routing protocols. Means OSPF properties is also same. Okay, anything? What is the protocol number of OSPF?
89.
89.
Protocol number is 89. Very good. After that, what addresses, multicast addresses OSPF are using?
Generally, it is
So
used
224.0.
224.0.0.0.5
0.0.5 and 6.
and
Well,
6.
yes, we have two
6 for
multicast
DR and
address over
BDR.
here: 224.0.0.5 and 224.0.0.6.
6.
Okay, on this
Okay.
address, actually all routers are listening on this address. All OSPF enabled interface will listen on this interface. We can say directly listen by all routers, and this address will be
For
listened
DR
by,
and BDR. Other
yes,
routers will communicate to DR and BDR using this.
exactly,
So DR and BDR would be participating in both this multicast address.
exactly, listened by DR and BDR. So in OSPF we have two multicast address. One is 224.0.0.5 and 6. Okay, anything else?
AD value, sir.
Okay, AD value. It uses what AD value?
90.
110.
90?
110. 110.
110.
110.
110. Okay. After that, we can discuss the metric. So what is metric over here? Metric is
Cost.
cost in
Cost
OSPF.
Cost.
And what is the formula to calculate cost?
10 to the power
Reference.
7.
No,
10
no,
to the
no.
power 7.
Reference bandwidth.
Reference bandwidth upon my interface bandwidth.
Yes, reference bandwidth divided by bandwidth of your
Interf
link.
interface.
Yes, we can say bandwidth of link, right? And by default reference bandwidth is what?
100
10 to
Mbps.
the power 7.
No,
100 Mbps.
100 Mbps.
For fast Ethernet only, no, sir.
No, by default
No.
reference bandwidth in OSPF is 100. By default reference bandwidth that is configured on OSPF router is 100. If I will enable
Okay.
OSPF on any router, let's say this is my router 1. Here I am going to enable just OSPF. I have only configured IP address on all routers. So IP protocol, you can see I am not running any protocol. If I will enable OSPF, router OSPF and then process ID 1. After that we need to define router ID, let's say 1.1.1.1, and after that to advertise networks or to enable OSPF on interfaces we need to run network command. Network, let's say network 10.1.1.0/24, sorry, wildcard mask 0.0.255 and area 0. This is the command to enable OSPF. So what I am asking you that what will be the metric on this link? I have enabled OSPF on fast Ethernet 1/0. So IP interface brief exclude unassigned. So I have enabled OSPF on loopback 1 interface. Let me configure this IP address on physical interface, not on loopback interface. Let me delete this loopback for now. On router number 1, I'm going to say no interface loopback 1, no interface loopback 2, and no interface loopback 3. Done. And interface F1/0, no shut, and IP address is 10.1.1.0 0.0.255, and area is sorry,
So you type or wildcard
I
mask.
am defining the IP address now, na?
Mm,
One
subnet mask.
Yes, subnet mask here I need to put. Okay, so I have enabled OSPF on one interface, that is F1/0. Okay, so IP OSPF interface brief. You can see I have enabled OSPF on fast Ethernet 1/0. Now here, if you want to check the reference bandwidth, what is the command? So IP OSPF process, I think OSPF, after that process number 1. Like this also we can check the reference bandwidth. So what is reference bandwidth here? 100 Mbps.
100.
Okay, so by default reference bandwidth is 100, and here I need to calculate metric of this link. So OSPF will calculate metric like 100 divided by link bandwidth. So bandwidth of link in Mbps is what? So interface F1/0 include, we can say include bandwidth. Bandwidth in Mbps is
100 Mbps.
100 Mbps, right? So what will be metric of this link?
1.
1. Metric will be 1. Getting my point? Here
Sir,
if
we
I
can change the reference bandwidth, no,
yes,
sir?
we can change the reference bandwidth.
According to your requirement.
Yes, according to the requirement. We need to change the reference bandwidth as well in some scenario. Like let's say I have one topology here, router 1, router 2, and router 3. Getting my point? Here router 1 is connected with both router have one network X, right? Both router 2 and router 3 will advertise X network to router number 1. Let's say here this link bandwidth is 1 Gbps and this link bandwidth is 100 Mbps. So according to OSPF, metric on this link will be what?
100 by 1 Gbps.
100 by 1 Gbps means 0 point something, and it will consider 0 point something, 0 point something by 1
Integer value 1.
to 1. Yes,
1.
integer value. So metric over here will be 1 and metric over here will be also 1, right? So in this scenario actually OSPF is calculating same metric on both link, but you can see bandwidth of both link is not same. Here we have more bandwidth. So in this type of scenario we need to change reference bandwidth. Whenever we have more than reference bandwidth, whenever our link have more than bandwidth of more than reference bandwidth, in that scenario we need to change reference bandwidth value. By default it is 100. Okay,
Okay.
by default it is 100, and whenever you have more than, you have a link of more than 100 Mbps and you are running OSPF, in that scenario you need to change the reference bandwidth, otherwise it will calculate reference bandwidth 1 on all the link which have more than 100 Mbps bandwidth. Getting my point?
Yes, sir.
Okay, so by
Sir,
default reference,
recording is on or not, sir?
yes,
Recording,
yes,
sir?
recording is on, brother.
Okay, sir.
By default reference bandwidth is 100. So on fast Ethernet link, if I will talk about the fast Ethernet link, on fast Ethernet link, what will be the cost? On fast Ethernet cost
1.
will be always 1.
1.
On Ethernet link, what will be the cost?
19.
10.
10.
10. Okay.
100 divided by 10 is equal to 10. On serial link, if you will calculate the metric on serial link, so it will be 64. Okay, so these are the basic concepts of OSPF, like AD
What's
value.
the speed of the on serial link, sir?
So see, around 64. See here, if I am connecting one serial link. I will show you the bandwidth of serial link later, don't worry. I will use serial link between two devices and then I will show you what is the bandwidth of serial link. Right?
The 5
But
point
if you will
some-
divide it,
5.4 or something.
if you will divide the bandwidth of serial link by 100, you will get value 64. Got it? 64 point something, so it will consider as it as 64. I remember the cost on serial link, cost of OSPF. After that, guys, if I will talk about the types of message in EIGRP, how many types of message are there in EIGRP?
5, sir.
Hello, update.
5.
5 types of message are there.
Yes, sir.
In OSPF, we have also 5 types of messages. First is
Hello.
first one is hello, and use of hello message is same over here also. One is to discover neighbor and second one is keep alive. Second type of message is this is hello message is also known as by type 1 message. Type 1 hello message. Type 2 message.
DBD, database description.
Yes, type 2 is DBT,
DB.
database description. Then type 3.
LSR.
Type
LSR.
LSR. Link state
LSR.
request.
Request.
After that, type 4
LSU. Link state update.
LSU. Link state update, and then fifth type of message, that is type 5 message.
LSCA.
Which one?
Link state upload. LSCA. sir.
LSAC. Link state acknowledgement. So we have 5 types of message in OSPF also. Okay. Hello message is used to discover neighbor and keep alive. Router will send hello message on what address? Router will send hello message on what address?
24005.
Yes,
5.
224.0.0.5.
5.
And unicast in case of static neighborship. Here also we have 2 types of neighborship in OSPF, static and dynamic. In dynamic, it will send hello message on this address, and in a static, hello message will be sent by router on unicast address. Let me discuss hello message in detail, guys. Here heading is, let's say, hello message. What I am saying, in case of dynamic neighborship, in case of dynamic neighborship, hello message will be sent on this multicast address, and in case of static neighborship, it will be unicast. Okay. After that, if I will talk about the content of hello message, so what will be the content inside hello message? Version. There will be information about version.
Router ID.
First
Router ID.
information. Yes. Then the current version is version 2. Okay. After that, there will be type field. At which type of message it is. So it is, let's say, hello message. So type value will be 1. Type value 1 is the type value of hello message. After that, there will be information about the length. So length of packet, definitely we can ignore it here. Then there will be main information, router ID. After that, there will be authentication type, authentication data, then subnet mask, date, timer, and date timer and hello timer. Hello timer will be there inside the hello message. After that, there will be information about DR router ID. Guys, it is very important. Try to understand content of hello message very carefully. Otherwise, it will be difficult for you to troubleshoot OSPF neighborship. So in the hello message, there will be information of DR router ID as well. Who is DR. Okay. After that, BDR router ID will be also there. BDR router ID. Then, okay, so these are the common information and important information that hello message carries. And to form OSPF neighborship, there are some neighborship parameter. May I know that parameter? Parameter is first of
Same
all,
hello timer.
router ID must be unique.
Yes.
Let's say we have two router. Router 1 and router 2. First condition is router ID of router must be unique. R1 and let's say R2. Here router ID is 1.1.1.1. Here router ID is let's say 2.2.2.2.2. So neighborship parameter first requirement is router ID. Router ID must be not same, must be unique. Router ID must be unique. Done. Then
Hello timer.
Hello timer.
hello timer and date timer, or only hello
Yes.
timer?
Both.
Hello and date.
MTU. MTU
See,
should be same.
in EIGRP also hello timer should match or not?
No.
No, in EIGRP it's not required, but in case of OSPF, hello timer and
should
date
match.
timer must be
Same.
Then
MTU.
MTU, okay. MTU must be same.
Authentication if any.
Authentication, okay, if authentication is configured. After that, subnet.
Subnet mask. Subnet mask or
Subnet
wildcard mask.
mask must be must match. Then authentication, okay, if we have configured the authentication, so authentication data should also match.
Network type.
Authentication type as well as
Network type.
authentication data, then network type also. Then network type.
Yes.
Network type must be same.
Same.
Then
Answer area ID.
area ID, very good. Area ID must be same.
Same. For
Then
the same link. Then MTU.
anything else?
Sir, if different areas are configured, then it should make sure that those are connected with area 0. I mean,
Definitely. Then stub flag must match.
Yeah, that word I forgot.
Yes, stub flag must match. So these are requirement of neighborship in case of OSPF. Router ID is 32 bits address. Now who will explain that how router elects router ID? Question is how router elect router ID. It is an 32 bits unique identification of router, we can say. Router ID in OSPF is nothing but unique identification or 32 bits unique identification of a router. But question is how router will elect router ID?
Sir, it has three. It will elect in three way. First priority it will give for the if the loopback IP address is
First of all,
configured.
manual. First of all, manually we can configure router ID manually on router. So first we have two options. One is we can configure manually. router ID on router by running command what? Router OSPF process ID 1 and then router ID.
Hyphen ID.
Let's say 1.1.1.1. This is the first way to configure router ID on router. The second way is
Highest loopback IP address.
dynamic. Yes. In dynamic, if you will not manually define the router ID of router, then it will check what? Loopback.
Loopback IP address or the physical IP address.
Highest. Okay, if we have more than one loopback exist on router, then which IP address will become router ID? Highest loopback IP address. Okay. If there is only one loopback is exist on router, so that IP address will become router ID. Okay. If loopback is not exist on router, then
Highest interface.
highest physical interface IP address. Okay, then if let's say on a router I have not configured any IP address on loopback interface, not on physical interface, and I have run command router OSPF1, then router will elect which router ID? 0.0.0.0. Done. If we have not configured any IP address on router, just I have configured what? Only OSPF. We have enabled the OSPF. So router need router ID. It will look for the loopback. So loopback is not exist. Then it will look for the physical interface. Physical interfaces are also not up. So it will elect their router ID as 0.0.0.0 and it will enable OSPF process. Guys, router ID in OSPF is very important because with router ID only router will represent their database. Let's say in a domain we have 10 routers. So each routers will create their own database. So routers represent their database with the help of router ID. You think my point? So now on this router, here what will be the router ID on this router, guys? Here I am running one IP address on F0/0 also, and see the IP configuration on router number 1. So IP interface brief exclude unassigned. This is the IP configuration of router number 1. Can you tell me what will be the router ID of router 1? Here I have already enabled OSPF.
12.1.1.
But I am not running OSPF over here on this interface. OSPF is enabled only on this interface. Then also this IP address will become router ID or not?
Yes, sir.
No, sir, we are running on an interface, this particular interface.
No. So we are enabled OSPF only on this interface. It doesn't matter. You are running OSPF or you have enabled OSPF on loopback interface or not. If loopback is exist, so IP address of loopback interface will become the router ID of router. So IP protocol. By running this command, we can verify. The router ID is what? Here 1.1.1, because manually I have defined 1.1.1 router ID. Now I am going to say router OSPF 1 and no router ID 1.1.1.1. I have removed this command from here, and so IP protocol. Now you can see router ID is what? 12.1.1.1. Now I am going to remove the IP address from this interface. Interface F0/0. On F0/0 I think I am running 12.12 network. So I am going to say no IP address and so IP protocol. Now what is the router ID of this router? 12.1.1.1. Even this interface is not done, and this interface F0/0 does not have any IP address. So IP interface brief. Router is not using this IP address. Now you can see, but still router ID is what? 12.1.1. So once router will elect one IP address as their router ID, doesn't matter you have removed the IP address from that interface or from the loopback interface, router ID of OSPF is not going to change.
You
OSPF
have to
router ID will
reload
be
the
same.
router, means you have to
Yes.
reload the router, then
Not
only
router,
you'll be changed.
OSPF process. We need to reload
OSPF
OSPF
OSPF.
process. We can say
Clear
clear
OSPF.
IP OSPF
Process.
process
ID1.
1. Process, say yes. And so IP protocol. Now router ID is what? And now I am going to remove IP address from this interface also. Interface F1/0, say no IP address. I have removed the IP configuration from here. And it is saying, okay, this interface failed to remove the IP address. Do so IP interface brief. So now we don't have any IP address on any interface. So IP protocol. OSPF is using this IP address as router ID. Clear IP OSPF process, say yes. And so IP protocol. Now what will be the router ID? Sorry, clear IP OSPF process. I think it have not cleared. So IP protocol. Let me do one thing. Here I am going to remove the OSPF configuration, no router, OSPF process 1. Done. Do so IP interface brief. Now we don't have any IP address on any interface. Now router OSPF process 1. Now this time what will be the router ID? So IP OSPF, so IP protocol. This time router ID is 0.0.0. And once I will configure IP address on any interface, let's say on F0/0, I'm going to configure the IP 12.1.1.1 255.255.255.0. So this IP address will become a router ID. So IP protocol. Okay. And if I will configure one loopback interface F1/0. Now if I will configure the loopback interface, tell me, will loopback interface will become router ID or router ID will be remain same 12.1.1.1?
Sir, it will remain same. It will not change.
Yes, it will not change. OnSoughter will elect one IP address as a router ID. Even you are creating the loopback interface with higher IP address, doesn't matter. There is only one way to change router ID now, that is manual configuration. And once router will form neighborship, after that you cannot change the router ID. See, here I have configured the IP address on both interface now. So IP interface brief exclude unassign. I have configured the IP address on both interface. Let me enable OSPF on both interface. Here I am going to say router OSPF process ID 1 and network 12.1.1.0 0.0.0.255 and let's say area 0 for now. And we can enable OSPF with network command also, and we can enable OSPF on interfaces directly like F1/0, and here I can say IP OSPF process 1 and then area 0. Like this also we can enable OSPF. Now let me take you to router number 2 and let me configure OSPF on router 2 also. Before that, let me check the IP. So IP interface brief exclude unassign. So here I have one IP address on F0/0 and one on F1/0, that is 23.1. Let me configure the LAN interface, that is interface F2/0, and IP address is 20.1.1.1 255.255.255.0 and say no set. Done. And router OSPF process 1 and network, or directly I can go to interface F0/0 IP OSPF 1 area 0 and interface F2/0 IP OSPF 1 area 0. So I have enabled OSPF on both interface. Now you can see OSPF neighborship is up. And here on router number 2, router ID is so IP OSPF, so IP protocol. Here you can see router ID is 23.1.1.3 IP address of fast Ethernet 0/0. Now I want to change the router ID of router 2. Let's say here I want to configure router ID 2.2.2, router OSPF 1 and router ID 2.2.2.2. See, I am not allowed to change router ID because router 2 have already shared their database to router number 1. See, on router number 1, if you will check the database, so IP OSPF database. So in the database of router 1, see, there are some LSA with router ID what? 23.1.1.2. So means router 2 have shared their database with this router ID. Now you are not allowed to change. If you want to change the router ID, so actually router need to tell to their neighbor that now my router ID is not this one. So you have to clear the process. Then only you can change the router ID. Okay. So on OSPF, router will form the neighborship and exchange their database. After that, you are not allowed to change router ID. So it is also saying you to reload your router. Use clear IP OSPF process command and then you can configure router ID 2.2.2. So once I will run clear IP OSPF process, this command say yes. So it will break the neighborship and now I can change the router ID 1, router ID 2.2.2.2. That's it. So this time it will share their database with what router ID 2.2.2. On router number 1, if you will run command this now, see, just wait for some time. So IP OSPF neighbor. Now neighborship state is in X start with 2.2.2. So it will take some time. And after that, so IP OSPF database, you will see there will be some LSA with 2.2.2.2. Yes, now you can see it have some LSA with router ID what 2.2.2.2. Advertise router is 2.2.2. Okay, is it clear, guys, to everyone? Now let me capture this link. If you want to see the content of hello message, here let me show you the content of hello message once. Let me open the hello message of any router. Let's say this hello message router 1 is sending to this address 224.0.0.5. Let me open this hello message here and let me expand it. See, this is OSPF header. Inside the header we have version information, types of message, length, then router ID, area ID, checksum, authentication type, authentication data. So these are the information inside OSPF header. After that, OSPF hello packet. Here we have subnet mask, hello interval, priority, we will discuss priority later, dead interval, then DR router ID and backup DR router ID, and active neighbor. So active neighbor information is also there inside the hello message. Active neighbor. DR router is 12.1.1.1 and BDR router is 12.1.1.2. Active neighbor is 2.2.2.2. When router 2, actually router 1 is sending this hello message to router 2. When router 2 will receive this hello message, router 2 will check this field, guys, active neighbor ID. If inside this field active neighbor ID, router 2 will found their own router ID, then only neighborship state will move from which way? Which state? Two-way state to X start state. So we are going to understand the states as well in OSPF, but these are the important fields. Okay, so wait, I want to discuss first OSPF neighborship state. Very interesting. OSPF, how OSPF is going to form neighborship. OSPF states. How many states we have? Number 1.
7.
Yes, number 1 is down. Number 2 is init. Init, or we can say attempt as well. In some scenario it will be attempt, in some scenario it will be init. Okay, after that two-way, then Rohit,
Then sir,
X,
start,
X start, then
exchange,
exchange,
loading,
loading,
full.
and full. Very good. So we have 7 states of neighborship in OSPF: down, init, two-way, X start, exchange, and loading, loading, and full. Okay, guys, there are 2 types of neighborship in OSPF. Types of, if I will talk about the types of neighborship, so we have 2 types of neighborship. First is neighbor with, or we can say without
Adjacency, without adjacency.
Adjacency. And second type of neighbor is neighbor with adjacency. Very good. So OSPF router will not share their database with neighbor without adjacency. OSPF routers exchange their database with only neighbor with adjacency. Okay. This is here our neighborship state will be full, and here our neighborship state will be till two-way.
Oh, yes.
Here our neighborship will be till two-way. So means whenever OSPF router will form a neighborship till two-way state, that means it is not going to share the database. If neighborship state is full, that means database has been exchanged between router. Okay, so see guys how it will work. First of all, let me take some router over here, R1. I have, let's say, 2 router, R1, R2. Okay, here is one loopback, R1, R2. Here let's say I have one loopback, that is 1.1. Router ID of this router is 1.1.1. Router ID of this router is 2.2.2.2. Done. Router ID of router 1 is 1.1.1. Router ID of router 2 is 2.2.2. What do you mean by down state? Can anyone tell me what is the meaning of down state? Here let's say IP address is 12.1.1.1.
No neighborship between them.
No neighborship?
Yes.
No. See, when I will enable OSPF on router number 1, I will run command router OSPF OSPF 1 and then network 12.1.1.1, and before it I will define the router ID 1.1.1.1. I will run these command on router number 1. Once I will run these 3 command, guys, what R1 will do, R1 will start sending one hello message. R1 will send one hello message from this interface, right? On what address? 224.0.0.5. And in this hello message, router will carry their own router ID. Because see, in the hello message, you are able to see there is one field called active neighbor. But in active neighbor field, now router 1 will put value 0.0.0 because router 1 don't know about their neighbor, right? On this link, router 1 have not discover any neighbor. It is sending their first hello message. It have not received any hello message from router number 2. So how router 1 can get to know what is the router ID of router 2? So inside the neighbor, active neighbor ID field, it will be 0.0.0. Done. So when router is actually sending hello message from the OSPF enabled interface and it have not received any hello message, so that interface will consider as down interface. Getting my point? Means I have enabled OSPF on that interface, on that particular interface. Router is sending hello message as well from that particular interface, but router is not receiving any hello message. Getting my point? That interface will consider as down. Down means not like this, the port is down. Means OSPF is enabled, but that interface is not receiving any hello message. Is it clear? Down state to everyone.
Yes, sir.
So once I will enable OSPF on router number 2 by running command router OSPF 1 router ID 2.2.2.2 and network 12.1.1.0 or 2.0.0.0 and network area. Okay, once I will run this command on router number 2, router 2 will also send one hello message. Yes or no? In this hello message, router will send their on router ID hello. In this hello message, router 1 is sending their on router ID 1.1.1. Here it is sending their on router ID 2.2.2.2. Now router 1 have information what is the router ID of router 2 and router 2 have information that what is router ID of router 1. Now both router can decide which router will become. Okay, both router can decide that on this segment, which router have higher router ID. Yes or no? Router 1 no. Okay, higher router ID is of router 2. 2.2.2. My router ID is 1.1.1. Router 2 will also came to know. Okay, on this link, I have one neighbor whose router ID is 1.1.1, but my neighbor, my router ID is 2.2.2, which is higher. Yes. Yes or no? So once router will receive a hello message on this interface, first of all, state will move from down to init. Init means initialization. In init state, routers receive hello message with neighbor router ID only. So see, in the hello message, router 2 is actually sending their own router ID only. Okay. In next hello message, when router 1 will send the next hello message, in this hello message router 1 will share their on router ID also, that is my router ID is 1.1.1 and active neighbor is 2.2.2.2, and once router 2 will see their on router ID in hello message, state of that interface will move from init to two-way. State will move from init to two-way. Two-way state means router have checked, router have seen their on router ID inside the hello message. See, this is the capturing over here between router 1 and router 2. Now what I am going to do, I am going to down OSPF neighborship here. Config T interface F0/0 says shutdown. I've done the interface, OSPF neighborship will goes down. Done. It is not sending any hello message. It is not receiving. Yes, it is sending hello message, but it is not receiving any hello message. And see, router 1 is sending, this is hello message. I have run no shut command or shutdown command. So router 2 is also sending hello message and router 1 is also sending hello message. In the router 1 hello message, if you will expand it, active router ID is still 2.2.2, means let me do one thing. So IPOSPF neighbor.
Sir, it is waiting for dead interval to end.
Yes, it is waiting for dead interval. Just wait. Now you can see Who is sending? Router 2 is sending this hello message, and in the hello message in header, SPF header, you can see area is 0.0.0, self router ID, source router ID is 2.2.2, and after that, is there any information about active neighbor router ID? No. Designated backup designated router? No. Router 2 is declaring their self as DR. In the same way, router 1 is also sending, let me check the hello message of router 1. Router 1 is not sending any hello message now. Okay. Now I am going to run nosut command again on the interface. Interface F 0/0 and say nosut. Where is the first hello message of router 1? This is the first hello message of router 1. In first hello message, designated router ID is 0.0, backup designated router is 0.0.0, and router 1 is sending their on router ID only. 12.1.1.1 is the router ID of router 1. Okay. So with this hello message, when router 2 will receive this hello message, the state will move from dawn to init, because in this hello message you are not able to see neighbor router ID. You are not able to see neighbor router ID here. This is the first hello message of, I think, router 2. So router 2 is also, you can see, sending their on router ID only, and active neighbor is 2. This is not actually, I think, first hello message of router 2. Router 2 is sending this hello message after receiving hello message from router number 1. So when router 2 will actually receive the hello message from router number 1, and after that, whenever it will send hello message, in that hello message there will be active neighbor router ID. And when router seen their on router ID in active router ID field, active neighbor field, states will move from init to two-way. Actually, two-way state means what? In two-way state, we are checking bidirectional connectivity. Bidirectional connectivity is checked in this state. After that, DR and BDR election is happening on this state in two-way state. In two-way state, router decide which router will become DR and BDR. Bidirectional means router are checking their own router ID. If router are able to see their own router ID in hello message, that means there is bidirectional connectivity. After that, router will decide which router will become DR.
So this
And
will
BDR.
decide in X start state, I think.
DR and BDR.
Hi,
No, DR and BDR election will happen in two-way state. In X start state, router exchange database.
They decide which going to send the data.
Yes. In two-way state, DR and BDR election will happen. Okay, guys. Okay. Okay. So router 1 and router 2 will form neighborship till two-way state. Here till now we had discussed the neighborship state till two-way. Okay. If router 1 and router 2 will not move their neighborship from two-way state to the next state, that is X start state, then router is not going to exchange database. Okay. So here we have some concept of DR and BDR, like DR other and DR other cannot form full adjacency neighborship. So neighborship state will stuck over here, two-way state. It is going to check, actually routers are going to check on the segment, on this segment, means this segment, how many routers are there? 2, router 1 and router 2. So one router is DR, one router is BDR. Let's say I have connected router like this. Router 1, I'm connecting router with one switch like this. I have one switch over here, and through this switch we have some router R1, R2, R3 and R4. See, these all rotors are connected in same segment. So on a single segment, only one rotor can be DR. Like if I will talk about this topology, in this topology on this segment, only one rotor can be DR and one rotor can be BDR. Okay. In this segment also, in same segment, we have 4 rotor now. R1, R2, let's say, R3, let's say, and R4, let's say. Router 1 have router ID 1.1.1.1, router 2 have router ID 2.2.2, let's say, and router 3 have router ID 3.3.3.3, router 4 have router ID, let's say, 4.4.4.4. This is your switch. So here one router will become DR, one router will become BDR. Let's say router 4 is your DR router. Router 4 is DR and router 3 is BDR. And router 1 is DR other, and this one is also DR other. So neighborship between DR other and DR other will be till two-way. Okay. And neighborship between DR and DR other will be full. Yes. Full. Neighborship between DR other and BDR will be
Full.
And neighborship over here between BDR and DR other full. Here also we will have
Full.
neighborship. Means router 1 and router 2 are not going to exchange their database with each other. Why? Because here you can see database exchange will happen in which state? In X start state. And neighborship between router 1 and router 2 is till two-way. So till two-way we had discussed that there is no any exchange of database. Getting my point, guys?
Yes.
We will understand later that what is the need of DR, BDR here, what is the concept of DR, BDR here. Now we are not discussing that. Just try to understand neighborship states only. Means till two-way we have not here any database. Means router 1 and router 2 will not exchange database. Now again let me take you to my example between two router 1, router 2. Let's say both router have exchange hello message, right? Now till two-way state we have discussed the process. Now let's understand after two-way. Let's say router 1 is not DR other and router 2 is also not DR other. This is, let's say, DR and this is router 2 is BDR. So it will form full neighborship adjacency. So after two-way it will came to know that okay, I am DR, router 1 will think I am DR and router 2 is BDR. So we will form full neighborship. So it will send what? DBD message. Router 1 will send what? DBD message. In which state? In X start state. DBD. Router 1 and router 2 will also send DBD. Now this is also, one concept also. We have one concept over here as well, that which router will send DBD message first.
It is decided in X start state on the basis of router ID.
And there will be one more election of router, master and slab.
Sir, in X start state that will happen.
Yes. So we are in X start state now. That's why it is sending. See, it is sending database description. Both router are sending what? Database description in X start state. Once router 1 will become DR and router 2 will become DR, both router will came to know that our states will be move in next state. DR other and DR other will stuck in two-way state, and all DR others with DR or BDR will form what? Full way adjacency. So it will send database description. The purpose of database description message is to exchange sequence number. The main purpose of DBD message is to exchange the sequence number. Both routers are going to exchange one sequence number. Because OSPF routing protocol is little bit different from other routing protocols like EIGRP. Here routers are going to exchange the database with sequence number. So in DBD, through DBD message, it is going to negotiate the sequence number. It is going to check MTU value as well here. If MTU value will mismatch, the neighborship will stuck in access start state only. Because through DBD, it is going to check MTU value. DBD message will carry MTU information. Okay. Yes, definitely we can ignore the MTU as well. Like if I will show you here, between router 1 and router 2, I think there is OSPF neighborship. Enable and so IP OSPF neighbor. Now you can see neighborship is full with 2.2.2.2, and here I am going to change the MTU interface F0/0, say IP MTU 1000. By default it is 1500, and here I have configured 1000. So tell me, will OSPF neighborship goes down?
Yes,
No.
sir.
No, brother, because neighborship is, already in full way. So IP OSPF neighborship is already in full way. Neighborship adjacency is full. So again, when router 1 and router 2 will enter in which state? In access start state. Then it will check what? MTU size. Not in full state. Now router are not sending any database. Database is already exchanged between router 1 and router number 2.
When next time database is exchanged, then it's going to be done.
Yes, exactly. So if I will run command what clear IP OSPF, let's say process, and say yes. Now it will not form neighborship again. So IP OSPF neighbor. Now you can see neighborship is stuck in which state? In access start state. Why? Because of MTU mismatch. So we can run one command. If you want to ignore it, so you can run one command. Very simple command is that is, I think, interface F0/0 IP OSPF MTU ignore. Yes, this command. If you will run this command, that means I am forcefully telling to router, please ignore MTU. And again you can see OSPF neighborship is in full state. But by default in access start state, routers will check MTU as well. So MTU should match. If MTU will not match, then neighborship will stuck in access start state. So let's say if MTU is also same, then both routers have exchanged what? DBD. This is empty DBD. There are nothing inside this DBD. Routers are exchanging only sequence number. Okay. Okay guys, till here, anyone have any doubt?
Sir, it is first time DBDs share to check the connectivity.
Not connectivity, to exchange the sequence number, and it will negotiate MTU. Master slab election will also happen in this state. Okay. To decide which router will see a database first, one router will elected as master router. Router which will have higher router ID, that router will become what? Master. Okay. On router will exchange DBD message, database description, empty DBD, and MTU is matched. Once MTU will match, neighborship will move in which state? Exchange state. Exchange state. Guys, in exchange state, see, let's say router 1 have some network. Router 1 have, let's say, 3 network, A, B and C. And router 2 have some network, let's say X, Y and Z. Router 1 have also 3 network, router 2 have also 3 network. So in exchange state, router will share the network link header. Network header. Like router 3 have 3 number of network ABC, router 2 have 3 number of network XYZ. So it will share their header. Like router 1 will tell to router 2, brother, I have some network. Let me share the header of all network. I have network A, I have network B, and I have network C. This is not the detailed information of this network. Just it is sharing header of this network. Header is like menu card. In the restaurant, in the menu card, you will have, name of all foods available in the restaurant. So first of all, you will check what? Header, menu card. Then maybe you will order burger. So this is menu card. In menu card, let's say it is telling you that I have A, B and C. So let's say router 2 don't know about C network. So it will send the request message for C, and then router 1 will send detailed information of C only. If router 2 don't have any one network ABC which is receiving in this header, so it will request for all the network and it will send detailed information of all the network. So in exchange message, both router will share their DBD header. This is what, not DBD, we can say this is LSA header, link state header.
Link state
LSA,
advertisement.
not advertisement. Yes, this is link state advertisement, but it is header just, not the actual message. Okay, inside this header I will show you routers will not share the detailed information of this network, because actually routers, OSPF router are going to change the detailed information of link. So let's say router 1 have 1000 prefixes or 100 prefixes, let's say. So router 1 need to send the detailed information of all 100 prefixes to router number 2. So first it will send the header of all 100 prefixes, and router 2 will send the request maybe for all prefixes or for some prefixes, and router will share detailed information of those prefixes only which router 1 have received request from router number 2. Okay, router will send header of LSA. See guys, let me make you understand how OSPF work first. OSPF is a link state routing protocol. Let's say I have one router here, and on this router I am running, let's say, some interface are there, F0/0 and let's say F0/1, right? So here this is F0/0 and let's say this is F0/1. Here I am running IP, let's say 10.1.1.0/24, and here I am running IP 20.1.1.0/24. It is a link state routing protocol. OSPF is a link state routing protocol. So when we enable OSPF on these interfaces, what router 1 will do? Router 1 will create one database. This is LSA, what we called it, LSA, link state advertisement. Okay, inside the link state advertisement, router 1 will keep link state information like link type, after that link IP, then like link network ID, then like yes, link subnet mask, then link, cost, these information. Getting my point? It will create what? LSA. This is nothing but LSA of router number 1. We will discuss later as well about the OSPF, working, that how router build database. For now, just try to understand that in DBD, routers once router will enter in X start state. First, it will exchange DBD to exchange the sequence number, and for the MTU negotiation, if MTU will match, state will move in exchange state. In exchange state, router will share LSA header. Router will share LSA header. In header, just router are telling that I have network X, I have network Y, and I have network Z. Router 2 is telling to router number 1 that I have these prefixes. If you need, tell me. Okay. So this is which type of message? DBD, type 2 message. Sometime interviewer can ask you this question also, that type 2 message will exchange in which state? So tell me guys, type 2 message is sent in which state?
Exchange.
Of OS? In both X start and exchange. In X start it is sending null DBD, and in exchange state it is sending DBD with LSA header. Yes or no? Type 1 message. Router will send type 1 message in which state? In all state it will send hello message, type 1 message. State 1 to state 7. Type 2 message. It will send type 2 message in 2 state. X start and exchange. And once DBD will exchange, now router need detailed information. So state will move in loading. In which state? Loading. And in loading state, router will send what? LSR. Router will send LSR, link state request message. Let's say router 1 have sent one LSR message. LSR. In LSR it will, why it is sending LSR? Link state request, to request for the detailed information of X network, Y network, and Z network, right? And in the loading state, router 2 will send what? LS U, link state update, and in link state update it will share detailed information of LSA. LSU. And after that, once router 1 will receive LSAU, router 1 will send what? Acknowledgement, LSAC. Okay. So type 3 message, type 4 message, and type 5 message, all messages will be sent by OSPF router in which state? In which state? In loading state. And once router will exchange these all messages, state will move from loading to full. And full state means OSPF have exchanged their database. Okay. So is it clear to everyone? 7 types of states.
Yes, sir.
So type
Anyone have
Type
confusion?
1
Yes.
is used in all 7 stages.
Yes. Hello message will be sent by router in down state also, init, two-way, X start, exchange, loading, full. Anytime router can send hello message.
And type 2 in start and exchange.
Yes.
And type 3, 4, 5 is in loading state.
Yes, exactly.
There
Very
are the 5 type of message types
There are 5 types of messages in OSPF.
I'm talking about types. Type 1, type 2, type 3.
So you can say, type 1 is hello message, type 2 is, sometime it is saying type 1, sometime it is saying hello message directly.
So what's the purpose of sequence number exchanging?
Okay, so we will understand this
Okay.
Don't worry.
Okay. Okay.
Okay, so we have separate topics, sequence number in OSPF. You will understand while discussing database. Anything else? Any other dot, guys? First, try to understand, Rohit, small things. Then we will, connect everything together. Now we are going to understand types of LSA first. Types of LSA. So we have several types of LSA as well. May I know how many types of LSAs are there?
Maybe 11.
Yes. Okay. So now let me discuss about the types of LSA ones here. Types of, and see here, brother, if you want to see the messages practically, so let me show you. I have capturing. Yes. See, both router were exchanging hello message. After that, see, router 1 have sent one unicast DBD message to router 2, right? Then router 2 have also sent one DBD message to router 1. Again it have sent, router 2 have sent one DBD message to router 1. Router 1 have sent the DBD message to router 2, right? Both have exchanged. See, so one DBD message is empty, one is with header. After that, request message, then update message, again request message, update message. Okay, and these are the acknowledgement
All those
messages.
messages are unicast from
Yes.
description.
No. See, update message.
Description is not a unicast.
Yes,
Okay. Request and update is a unicast. Okay.
exactly. And at the last, it have sent the acknowledgement, and after that, it is not exchanging any more update message or any other message. Just it is sending hello message. And if you will check, brother, the router 1 configuration, like first of all, I need to identify that I am running OSPF on which interface. So IP OSPF interface brief. So I am running OSPF on these two interfaces, yes or no? So as I told you that once you will enable OSPF, it will keep information in their database in LSA. Okay, so this is a link, this is a link. So if you want to check the detailed information, so you can check so IP OSPF database. Inside the database, I am going to check the router LSA. We will discuss about the database, then you will understand why I am going to check this LSA only, router LSA. So router LSA of, see, there are router LSA of two router 2.2.2.2 and 12.1.1.1. 12.1.1.1 is the my IP address, router ID of router 1. Let me change the router ID of router 1 as well here. Router OSPF 1 and say router ID 1.1.1.1. Now I am not able to change, so do clear IP OSPF process, say yes. And now I am going to say router ID 1.1.1.1. Done. I've changed the router ID. See, so IP OSPF database. In the database, there are only one LSA. Soon router 2 will also share their LSA. So IP OSPF database. So IP OSPF neighbor. So neighborship is in two-way state. It will take some time. Access start full. Done. So IP OSPF database. In database, you can see there are two router LSA. One is of 1.1.1 and one is of 2.2.2. This is the LSA 1 of router 1. This is the LSA 1 of router 2. I want to show you the detailed information of LSA 1 of router 1. So IP OSPF database. After that, router LSA of 1.1.1.1. See, okay, so this is header, This is the header information. After that, you can see this is the link information. This is the link information. This is LAN interface, and this is the interface which is connected to router 2. So link connected to a stub network. A stub network means directly connected network. We will discuss later. After that, network, yeah, subnet number 10.1.1.0. The network which is running on the link is this one. Then the mask is this one. Number of, okay, metric is 1. So these are the information. Here we have one link. On the link connected to which type of network. Maybe it can be point to point. It can be, you know, in upcoming day we will understand network type as well. After that, network on link, then cost of the link, and the submit mask of the link. Then one more link connected to a transit network. Designated router address is 12.1.1.2. See, on the Ethernet link, OSPF consider their neighbor as a link also. Getting my point? On the Ethernet link, OSPF consider their neighbor as well as a link. And transit link, transit network, and stub network, we are going to understand about these network in upcoming day. We will understand how OSPF router can build the entire topology by looking towards their database only, because we need to understand the database of router. First, we need to run this command, so IP OSPF database. Now OSPF database is very small, I know, because I have configured OSPF only on router 1 and router 2, but in a coming day you will see the size of OSPF database will be very large, and inside that we will check the detailed information of each link. Okay, so now let me give you overview of LSAs, types of LSAs, and tomorrow we will start LSA. First is type 1 LSA. Type 1 LSA is,
Router LSA.
Router LSA.
yes, type 1 LSA is your router LSA. Then type 2,
Network.
type 2 LSA is
Network.
network LSA. Network LSA. Then type 3 LSA.
Summary LSA.
Yes, type 3 is summary LSA. Summary LSA. Type 4. Type 4 LSA. ASBR summary LSA. ASBR summary. We will understand about ASBR as well, but this is summary LSA. Then we have type 5 LSA.
External
Type
LSA.
5 LSA is external LSA. Very good. Then type 6 LSA. Type 6 LSA is MOSPF. MOSPF is not in used. It is not in used. So we will not understand this LSA, not in use. After that, type 7 LSA is in use. And type 7 LSA is NSSA.
NSSA LSA. External.
Yes, NSSA external
External.
LSA. Then type 8 LSA. Type 8 to type 11 are not in use. Type 10 to type 11 not in use. So we need to understand LSA 1 to LSA 5 and LSA 7 only. Total 6 number of LSA just we need to understand here. LSA 1 to LSA 5 and LSA 7. Can anyone tell me what is the use of this LSA, router LSA? And which type of router generates this LSA?
Every router in the same area.
Every
Matlab,
OSPF router generates.
every OSPF router. I mean.
Yes. Why?
So will
To share link state information. To share link state information, every router will generate this LSA. After that, network LSA. Which router will generate this LSA?
yeah.
DR router will only generate this
Yes.
LSA. And what is the purpose of this LSA?
For providing a like kind of a transit network which it will provide. Like for example, it will provide every link state advertisement for database.
No, it is generated by DR router, and the use of network LSA is to inform DR other router about attached router in a segment. In a single segment, let's say there are 10 router. So one router will become DR. All DR other router will exchange their database to DR router. In upcoming day, you will understand this also.
Yes.
Okay. So DR other router should have information about all routers in the topology. So with the help of network LSA, router will share attached router information in a segment. Okay, we will understand this also later. Okay, don't worry. Okay, summary LSA. Can anyone tell me which router generates summary LSA?
ABR, area border routers.
Why?
Because it is between it is on the boundary, so basically it is sharing between two different areas, so it will share
Yeah,
the
to
summary of
exchange
one
inter
area
area
to
prefixes.
inter-area prefix.
To share inter area prefixes. After that, ESBR summary LSA.
uh, this basically will be shared by ASBR.
No.
Sorry, it will be shared by ABR, but basically it will come in the form of this type 5, and this type 4 will be shared by ABR to other routers, saying that it has summary for
No.
link to reach
No.
to ASBR.
See, Neerab, all odd number LSAs are used to share prefix information or network information, and all even number LSAs are not used to share network information. Like if I will talk about the LSA2, even number LSA, network LSA, it is used to share attached router information, not prefixes. LSA1 is used to share link state information, means prefix information. LSA3 summary LSA is used to share inter-area prefixes, but LSA4 is again even number LSA. It is used to share ESBR information. Like ABR router will generate LSA4. Let's say I have router 1 over here, router 2 over here, router 3 over here, and let's say this is area 1, this is area 0. And this router is connected with one more router, and here I am running EIGRP protocol. Let's say EIGRP. Getting my point? So this router will become ESBR. Okay,
Yes,
if
yes.
anyone don't know about ESBR, don't worry, right? And router 2 will share these prefixes of this domain into this domain,
Yes.
and router 2 will tell to router 1 that router 3 is ESBR, and
Yes,
ESBR router is advertising the prefixes of EIGRP, right?
Yes.
So this LSA is again used to share the information of router. Which router? So ESBR router.
So,
After that, external LSA.
So basically, R2 is telling R1 no that why
Yes.
if you want to reach
ESBR will
ASBR, you
generate
can
both LSA.
yeah.
Summary LSA as well, and ESBR summary LSA as well. Summary LSA to share inter-area prefixes,
Yes.
and ESBR summary LSA is to inform the other area about ESBR router. It will share the ESBR router is 3.3.3.3. Maybe this is router ID of router 3. Okay. So you upcoming day you will understand why it is required and how router 1 can calculate metric to reach let's say here we have one prefix x, 4x prefixes. Getting my point? So for that, router 1 should have knowledge about the cost to reach ASBR, and ABR router will tell to router 1 what will be the cost to reach ASBR. Okay. After that, next type of LSA is external LSA, and this LSA is used by which router?
ASBR.
ASBR router to share
External prefixes.
external prefixes in OSPF domain. And then NSSA external. What is the use of this? Which router will generate this LSA?
ASBR only will generate.
Okay, why?
Because say for example, if we don't need to flood a particular area with extra routes, then we can configure NSSA
Yes.
on an ASBR. So what it
Okay.
will do is it will stop some of the type 5 LSS from other external prefixes, which are coming, which are not locally connected, but are coming from
Yes, or
other end.
simply Nirav, you can say if I will filter LSA 5,
Yes, yes.
then ASBR router will convert LSA 5 into LSA 7.
7, yes, yes.
So upcoming day we will understand this also, that why we need to filter LSA 5, and then how we can allow external prefixes in OSPF domain with the help of NSSA LSA.
Okay.
So tomorrow I will start LSA part, right? First we will understand the LSA 1. Through LSA 1, in all LSA, the most important LSA is router 1 LSA. This LSA. This one is most important LSA. By checking this LSA, router can design the entire topology. Okay. So tomorrow our main focus will be to understand the router LSA of router. Like this is the router LSA of router. On router number 1, I'm running command so IP OSPF database. So this is here, you can see router LSA. This is the router LSA. The router LSA of router 1, and this is router LSA of router 2. And guys, in all LSA there will be two information: link ID and advertise router ID. So we will discuss about this also in next class. And we have sequence number over here. So sequence number of router who is advertising this LSA means 1.1.1 have advertised their last link state information with sequence number 2. If I will add one loopback of over here, so it will increment sequence number by 1 in their LSA 1. Getting my point? Let me add one loopback 1 over here, loopback 1, and IP address is, let's say, 50.50.50.50 255.255.255.0 and IP OSPF network, IP OSPF process 1 and area 0, and so IP OSPF database. Now you can see sequence number over here is increased by 1. So whenever change will occur in which LSA? In LSA 1, it will update the sequence number. And whenever change will occur in LSA 1, router will perform what? Router will perform SPF algorithm.
Yeah.
If I want to check that how many times this router have learned SPF algorithm, I can run command so IP, I think OSPF process, so IP OSPF and then process number. By running this command, can I check how many times this router have executed SPF algorithm?
Yes. SPF
Yes.
algorithm executed 3 times.
Yes, SPF algorithm executed 3 times. And again, if a change will occur in LSA 1, it will execute their SPF algorithm. Interface, loopback 1 and say no IP OSPF 1 area 0. I have removed the OSPF configuration from this interface, means change occur in which LSA? In LSA 1. And again, if you will run command so IP OSPF 1, you can see it has executed 4 times. Right?
Yes.
So whenever change will occur in LSA 1, router will perform SPF algorithm. And as you know, whenever router perform SPF algorithm, it uses their CPU utilization.
Yes.
right? So in upcoming day you will understand how we need to reduce it as well. We need to take care of it, that router should not run SPF algorithm again and again. Okay.
For that only hierarchy